let's talk about arctan in this lecture. Again, like arcsine, arccosine, y equals tangent x. Again, it's not a one-to-one. You draw a horizontal line, you have many intersections for tangent. So apparently, we like to restrict our domain from negative pi over 2 to the positive pi over 2. So it's like sine x. So from quadrant 4 to quadrant 1. So tangent and sine, arcsine and arctan, they are similar. Okay, the domain for tangent and sine we all restricted to negative pi over 2 to the positive pi over 2. Okay, now from here let's find some basic values first. So for the basic values, what we need to do is consider the unit circle. Okay, the unit circle for tangent, here is pi over 6. Then you know 1 over 2 divided by radical 3 over 2. You cancel these 2, you have 1 over radical 3. That's for tangent, pi over 6. Okay, you can do the same thing for tangent, pi over 4. That's radical 2 over 2 divided by radical 2 over 2, and that's 1. Okay, and then down here you have the same thing. Tangent, pi over 3. That's y over x. That's radical 3 over 2 divided by 1/2. 2 cancel each other, you got 3. Radical 3. Okay. Now, this is the thing we know already. The thing is that now we are considering arctan. Then arctan again is from value. Go back to the angles. So value here is 1 over radical 3. You get the angle, then it's pi over 6. And here you have arc, tangent. Here is 1. So what angle do we get? Pi over 4. And here we have arc, tangent, radical 3. What do we get? Pi over 3. So is the case for negative 1. You may write, and arc. Arctan, negative 1 over radical 3. Here is positive, so you got positive angle. Here is negative angle. This one. Okay, arc, tangent, positive 1 for this angle, negative 1 for negative angle. And here arc, tangent, it was positive radical 3, now we have a negative radical 3, we get negative pi over 3. Okay. Yeah, so you want to be convinced, if I give you arctangent radical 3, you should find out, oh, that's pi over 3 from this basic thing down here. Okay. Yeah, and I give you arctangent negative 1. Hey, what is that? That's negative pi over 4. arctan -1 or radical 3 is negative pi over 6. So all the things actually we know from our basic facts. Okay. So down here is that for arctan, so y equals arctan x. What's the domain? What's the domain? You know, tangent x, it was actually a ratio. You see, 1/2 divided by radical 3 over 2 is 1 over radical 3. But you know, tangent 3, pi over 3 is radical 3. This radical 3 is already greater than 1. Okay, it's already greater than 1. Yeah. And here is the same thing for tangent. Tangent negative pi over 3 is negative radical 3. So it's less than negative 1. So basically for tangent x, the range is from a negative value can be less than negative 1. Actually, it's from negative infinity to positive infinity. Then you know that was the range for tangent. Then the domain will be opposite for arctan x. Then the domain will be the previous function will be the range. So the domain for arctan is from negative infinity to the positive infinity, since previously the range for tangent x is from negative infinity to the positive infinity. Can be less than negative 1, can be greater than positive 1. So that was a ratio. But we know that was the range. The domain for tangent was restricted from quadrant 4, negative pi over 2 to the positive. And then that was restricted for tangent. Now the domain for tangent comes to be the range for arctan. So that would be what? From negative pi over 2 to the positive pi over 2. Are those two boundary points included? If you remember, here was what? This point was 0, 1. This point was 0, negative 1. And tangent was y over x. Negative 1 over 0, 1 over 0 do not make sense. Okay? So then the boundary points are not defined. That's why, you know, I used the dotted line to show that was the asymptote. Okay? Alright, so it was not in the domain for negative pi over 2 to the positive pi over 2 for tangent. Then it will not be in the range for arctan x. Okay, so the output for arctan is restricted, and their input can be any real numbers. That was for arctan x. So to understand the function, you want to understand the domain and the range. This is from the point of view from the algebraically from here. And then, how about the pictures? Again, this was tangent, okay, and this was y equals x, this line. The inverse function of tangent x, which is arctan x, the graph of arctan x is you flip this red one based on this y equals x axis, you will get that. So previously there are two asymptotes. Now there are two asymptotes in horizontal direction. So we already know the domain for arctan x is negative infinity to positive infinity. And from this picture you can see clearly x can go as left as you want it, and y can go x can go to the negative, and then x can also go to the right as far as you want it. Okay, so this basically says that the domain is from negative infinity to the positive infinity, but restriction for output, the restriction for the output for arctan x is restricted to negative pi over 2 to the positive pi over 2. As previously you see it was like that. Okay, and you flip it, it goes in this way. Okay, remember again here, like sine is an increasing function when we restricted our domain from negative pi over 2 to the positive pi over 2. And cosine, arctan are also increasing functions, those two. Okay, and the thing is that for arctan it has asymptotes. Restricted, output is restricted in a band, and boundary points are not included. And these are different for arcsine. Arcsine, the boundary points are included. Okay, you may go back to review that. And the domain and range both are restricted. And here, for the range of arctan is not restricted. Okay, and the range is restricted in the band. The input is not. And arcsine, the input is restricted from negative 1 to positive 1. Okay? The output, they have the same domain, same range, but the input are different. Arctan x takes all the real numbers, and arcsine only takes from negative 1 to positive 1. The output are the same, from negative pi over 2 to positive pi over 2. So we had a picture for arctan, and we had special values. Okay?